Today's lesson is I can find the average value of a function over an interval. Before I go over the lesson, I'd like to describe what it is exactly that we're doing in this lesson. So the way to think about this is I've got a fish tank, and for some reason I have it in my hands and I'm sloshing it around and the waves are going everywhere, and I'm calculating an area. But then as I hold the fish tank still and the water settles, the water is in the shape of a rectangle. Well, it still has the same area even though it's in a different shape. But what I'm calculating in this case is not the area, but the height of that rectangle. So in our first box, we have the formula that you need to pause and write down. If f is a continuous function on a given interval, a through b, you're used to this, then the average value, in your mind, you're saying height, height, height. The average value is the height of the function on that interval, and here's the formula. You're used to a and b, but notice how you're using it in this formula. It's 1 over b minus a. It's similar to what we did with the trapezoid formula, but notice you're going to take a fraction of this area here. And when you take a fraction of that area, what you end up with is the height. So after you've hit pause and written this down, you can move on to the right part. Hopefully you have a blank like I do. And remember that the S part of this curve, that's the integral or the area. That's only part of the calculation. Our average value is the height of the rectangular with the same area. You're sloshing water that settles down into a rectangle, and you're taking the height of that rectangle. So the reason that you're multiplying by 1 over b minus a is that basically you are multiplying by the base. Remember, or 1 over the base. Rectangle is base times height. So if you divide by the base, what you end up is with the height, which is called the average value of the function. In our first example, find the average value of x squared minus 2x plus 1 on the interval 0 to 2. We're going to sketch that graph and shade the rectangle. Of the base, we're going to go from 0 to 2 on the x-axis, and the area is going to be the integral of x squared minus 2x plus 1. When I put that in my calculator, I get a parabola, and the shaded region is between the parabola on the x-axis, like when we first started doing integrals. But remember, I don't want the area. I want the height of the rectangle if that area changed shape. So I'm going to set up my formula like the one on the top of the page. My a value is 0, my b value is 2, so it's 1 over 2 minus 0 times the integral. The integral calculation does not change. And you can put this in your calculator exactly the way you see it. 1 over, in parentheses, 2 minus 0, using Math 9 and using your integral function. So this is what it would look like on your paper. But notice how I put the word calculator in red. Let the calculator do the heavy lifting. So it ends up being, I'm going to move this over here, 1/2, which is 1 over 2 minus 0, times 2/3. That's what your calculator is going to show as the area under the parabola, between the parabola and the x-axis. And you're going to say the height of the rectangle is 1/3. Now somewhere over here, I have the picture of the rectangle, but I'm going to have to hit pause for a moment and see if I can find it. Okay, so this is what it looks like when that area settles down. Here's the picture. So you can see I wrote over here that this rectangle with the same area as this has a height of 1/3. Here's the rectangle. That's 1/3 by 2. This is 0. This is 2. So it's 2 times 1/3 gets you back to the area, but that's not what the question is asking. It's asking what the height of the rectangle is. Next example. Find the average value. Find the height of the rectangle of the area when I use the integral. So I'm given the function x squared. I'm trying to find the area between -1 and 1, but from that area, I'm going to divide by the base. 1 over b minus a is the multiplier, and that's going to give me the height of that rectangle. Here I am setting up the problem. 1 over b minus a times the integral from -1 to 1, all in my calculator. It ends up being 1/2 times the integral. The calculator does the heavy lifting. It ends up being 1/2 times 2/3, or another height of 1/3. Number 2, another parabola from -1 to 2. Set up my problem. 1 over 2 minus -1 is 1/3. The integral goes from -1 to 2 of the parabola x squared minus x plus 1. Put that all in your calculator exactly the way you see it. The calculator will tell you if I divide 4.5, which is the area, by 3, the height of the rectangle with the same area is 1.5. Number 3, this is a cubic going from -2 to 1 on the x-axis. 1 over 1 minus -2 again gives me 1/3. I'm going to multiply 1/3 times the integral from -2 to 1 of the cubic. I'm going to get some pretty weird numbers, but since the calculator is doing the heavy lifting, I don't need to worry, except I may need to hit math, fraction, enter, in order to get it to be -5/1 over 12. That's the height of the rectangle with the same area. Let the calculator do the heavy lifting. In number 4, you can see that the interval includes x values in radians, so you want to make sure your calculator is set on radians. It's going to be 1 over pi over 4 minus 0 of the area between 0 and pi over 4 sine x dx, all in your calculator. 1 over pi over 4 minus 0 is 1 over pi over 4. You need to remember that 1 over pi over 4 is the same as 4 over pi, and the integral or area between 0 and pi over 4 sine x is going to be 0.293. Multiply 4 over pi times 0.293. The height of your rectangle is 0.373. Make sure your calculator is in radians. Please try the homework problems on the next page. That's page 6. I'll be back on Monday, and we'll be able to go over any of these problems and anything you don't understand from today's lesson.